Okay, now I want to make this sort of like some guidelines for this activity instead of being a 100% instruction, because I'm hoping that we're getting to the point where with all the practice that with the sim and talking and such that we can you guys can try to go through this on your own, but still I think it's worth giving you some help here. So we have the resistor code here, and don't forget that I pointed out to you, and let's pause this for a moment because we're not ready, or I lost it. So now I'm ready. So you have resistors in your kits, and I gave you there's 3 different values, and I think there's 2 of each in case something, you break one or you lose one, and they are right here. And so you can use this color chart to figure out what the values are, and then you can type into here. And now the keyboard's across out of my reach, and you can see if you got it right. You can use it as a double check. Okay, and okay, didn't see that maybe in one of the cameras you saw that I found these sitting on another part of my table. So the thing I wanted to show you is, though, too, I have it printed out. There's no reason that you have to have it printed out. And I also see now, once again, the best laid plans of mice and men. See, I'm more accustomed to students having a larger logbook, but we needed them quickly, and we'd already spent a lot of money on you guys. So we ended up giving you a smaller notebook than we normally do. So I always like to start on a fresh page, and so we have our date and time, and I see that it's 12:25, and my date, time, and initials. And right, this guy, well, it just about makes it. You really, basically, when you have a table in your book, you want to try to keep it, somewhat narrower than this. And so we have the we want to label what we're doing, the circuit theory, hands-on, if you will, or practical exercise, because up till now we've been using sims, and now we want to take real measurements. So now I've got a glue stick here, and I'm just going to do this quickly. I would advise when you do this to do it on a separate piece of paper, and then you can rub to the ends, not right on the table, and then like a scrap paper. And then, so now I'm going to glue this in, and it's a little too big. Now, if you don't have a printer, then you take out Mr. Ruler and you simply copy into your book the table and just use it as a model what I have in here. And so again, you don't have to print this if you don't worry about it. Just watch it on your screen, but you're going to have to put in the tables by hand. So now we've got our first activity, and I would advise having the logbook off to the side and being a little more organized. But then again, if you have a small space, you might not be able to be as clean and neat as possible. And we're going to need our breadboard all set up, and we have our 3 resistors. And so we have to connect. In this case, we're going to go from the positive rail, and yep, there's positive to the resistor, and then we use these are the much easier wires to use with the little black plugs on the end. The only drawback is they're kind of long. You're perfectly welcome to try using the little guys here. And now to the negative. And I have to turn it on. And now in principle current should be flowing. And so how do we measure the voltage? Well, let's now bring this down. Let's see if there was money well spent. Yeah. So yeah, it's an issue with the autofocusing. I don't quite understand. So our voltmeter, we have to set it to DC volts, and I want to get it into the picture. So as you've seen in the DMM basics, I know that I got about 7 volts there, so I'm going to need the 20 volt range. And so we can, now this is where the these SIPs come in handy. And first of all, let's just measure the battery itself. So we'll disconnect the resistor from the circuit. And so this is the negative rail, there's the positive rail, and nothing is happening. So that's not good. So let's double check that the battery, oh, you're not seeing this. I'm sort of wiggling the batteries in here a little bit. And I'm in the on position. So then I'll go back to the terminal block. And, so that's not registering anything. Okay, so that's fine. We need to look at another battery, and because there is a chance that maybe my battery, I forgot to turn it off. And this is what the battery charger is good for. This can be a little tricky. And holding these terminals, holding the probes on the terminals. And I see 1.6 volts. So something else must be wrong. So this thing has this plug here. It's because that's going to go into the Arduino at some point. So now I can do this. And nothing. Okay, so let's test directly to the batteries and nothing. And let's do this one directly to the battery. Alright, so we have, it looks like, a couple of dead batteries. So I'm going to pause this and I'll get other batteries. If I can see the pause button. Yeah, here we go. Okay, well, that was a pain in the rear end. I don't know what happened. I think it's just a question of getting these batteries fit pretty tightly in this case, and there's a spring on either end, and I tried rotating them in place. It could be, I don't know. Let's see now if it's still going to work. There we go. There's our 7.4 volts, 7.5 volts. So that works. Now, there is going to be, so make this one negative, and this one positive. So now, we measure this, and we see nothing. Let's make sure we're doing this right. Disconnect that for a second. And there's our 6 climbing. I don't know why. Now it could be our battery is, my battery is shot. Right down to 0. Okay. So I have discovered something interesting. I can measure. Now I've got it connected, I've got it turned on. And I measure the voltage here at the terminal block, and I get 7.12. But now when I measure it here at the resistor itself, I get, you have to really push it in there, 6.14. So that is really interesting. So I'm going to make myself a note here, 6, 30, 20, 20. And let's see, now it's almost 1 o'clock. And I'm going to say that, so I'm going to draw a picture here. Make a little sketch of the circuit. And then I'm going to say, wow, when I put the voltmeter in this position here, so DMM at position 1, I get 7.1 volts, but when I measure it at position 2, right, touching the probes right to position 2 on the resistor, I get, and I got more earlier. Well, the battery might be starting to run down. So I got 6.02 and 7.1. I think 6 point is a little low. but now it's even lower. So it's really interesting. But you know what matters is what you measure right there, and that. So 6.1, we'll 1.1, we'll call it 6.11. So 6.11 volts, and that's what matters. And then you can see here I made notes. So what it turns out, and I did some other measurements, it turns out that our assumption that the wires in the circuit board are zero resistance is not valid. And that, in this case, that really surprises me. The circuit board, I mean the breadboard, I'm really surprised. And one way we can overcome it is to take the connection here. Instead of using the rails, I can connect the resistor directly to the terminal block. And then I can measure the voltages. Let's see. So at the voltmeter 7.1, at the battery I mean 7.1, and at the resistor it's about the same. So it means that we tried being clever, and we tried setting it up with the terminal block and the rails. Well, we need the terminal block no matter what, but setting it up with the rails wasn't the smartest thing in the world. We kind of outsmarted ourselves. So then I wanted to also just see if I can get you guys a close-up of something here that I did. The when I'm taking the actual measurement. So you take your probes and you stick them right up against the two wires, and you can sort of push, if you do it right, you can sort of push down into the hole a little bit to force the probe against the resistor wire. So unfortunately, I'm thinking that it's best to blow off these this jumper business and just connect it directly to with the jumpers right to the terminal block there. Now, so again, I've measured the voltage, and it's that voltage at the resistor that matters. So then, now what we want to do is we want to take a current measurement. So to do a current measurement, we have to break the circuit. And this is again where one of these SIP things will come in handy. And so what I'm going to do is now I'm going to push that in there, and then the resistor is in row 14, and I'm going to plug in this jumper wire into row 13. Let's see if that can focus. Yeah, so you can see now, whoops, the resistor is in row 14, and I just plugged the jumper into row 13. So to get a current measurement, I'm going to set myself into DC amps, and I'm going to try 20 milliamps. So that's ready to go. And so it's current through. So now I'm going to restore the circuit. Let's do it this way. By touching the SIP pin that's in row 14, and then the other one is in row 13. And I went off the scale, so I go from 20 milliamps to 200, and there you go. Now I see 36.6. So now I go back to my logbook, and I write 36.6 milliamps, which is 36.6 times 10 to the minus 3 amps. So R equals V over I. So where is the calculator? It's all the way on the other side of my desk. But I have the ones I hand out during tests here. And so I have 6.11 divided by this thing does exponents. Yes. 36.6 exponent plus or minus 3 divide. And that gets me 167 ohms. And the nominal value, the barcode value, is 20 times 10 to the 1, which is 200. And one thing I can also do, I can disconnect. Oops. Oh, look at that. Oh, that's the screensaver. Okay, I don't know why the screensaver comes on. So I can now, let's do, so what I can do now, I'm going to disconnect the battery and set it aside for a minute. And I can take the DMM here, and I can set it to resistance mode, and see the ohm symbol there. And I'm going to use 200 because this resistor should work. I may have to change the range when I try it. And I can tell now that maybe I should have you guys measure this directly. So now I'm going to, just as before, go to the legs of the resistor. And I see that it's 197. So it's 197 by the ohm meter. So I'm going to say that R1 had, just a note to myself, R1 measured with ohm meter is 197. And so in fact, this, well, what I wanted you to do is look at the tolerance and see how good of a job we did. So the percent difference here, let's see, it's about let's say it's the difference between 167 and 200 is about 30. So that's a little bit more than 10%. That's like 15%. And let's see, this resistor has a gold band, and And the gold band is 5%. My word. But if you look at the gold band, this is only 5%. And excuse me, that's its tolerance is here, 5%. But if I compare 197, 200 minus divide by 200 times 100%. So 197 was the ohm meter. We're going to see that this is only a 1% difference, right? Or 1% is 2, so it's a little bit more than 1%. So it's about 1 to 2% difference. So in fact, this resistor delivers what the manufacturer promised. But that's not a big deal to us. We are just getting used to taking measurements and comparing things. So that is the first part. So go ahead and finish that, the Ohm's law part, and then we can discuss it.